kind of introduce what I'm thinking about when I think about data. Okay? And so we're going to talk statistics here and talk about what they are. But let me click on your well, actually, this is from a newer edition of the book, but I just like the problem so much I had to show it. All right? So, yeah, the newer edition of the book just came out this year. And here's their table in chapter 2. Your table talks about lead exposure, which is also an interesting problem. We may work on that today ourselves. Let's see what this table says. Drive-through service for McDonald's lunches. And they're measuring here in seconds, right? And you're looking at all these numbers. Does this mean anything to you when you look at it? I don't know. Let's take the first number, 107. What does that mean? Okay. So Calvin says a little under 2 minutes, right? Because 2 minutes would be 120, right? Because 1 minute is 60. But there's lots of different values here, and that shouldn't surprise us, right? It's not like everybody, well, you've waited in line longer than the other person. We all know what that feels like. At the grocery store. Did it ever take longer than 2 minutes? What's the longest one you see up there? 308? I didn't see that. Middle time. Oh, yeah. So how long is that?
That's 5 minutes.
That's more than 5 minutes to get their lunch. Fast food. What's the quickest? I see an 83, right? Okay. But here's the thing, is that it's hard to talk much about data if we don't organize it, right? Chapters 2 and 3 are about how we analyze data. Very simple ways of organizing, and then some more complex ways of analyzing data as well, okay? But all these numbers, it says, are service times for McDonald's lunches, right? And you can ask questions about this data. And so what I'd like you to do is, I'm going to pause here for just a minute. I'm going to have you introduce yourself, first of all, to someone near you. And then you're going to see if between the two of you, or three of you, some groups will be three, if you can come up with 3 questions we could ask about the data. And then we're going to list some of them up here. Okay? Go ahead. You know, one of the first things that everybody asked, because I heard people say, oh, mine was taken. One of the first things that people asked about for the McDonald's question is, can we say something about the average time it takes for a lunch, for a McDonald's lunch to be served? But then you'll notice people got more specific when they were writing on the board, because the word that statisticians actually avoid is this word right here, average. And actually, this is why I told you guys, hey, you know what? I'm going to be starting chapter 3 today. Okay? Let me show you why we're not starting in chapter 1, why we're not starting, right? We're starting chapter 2 today, and we're even going to get into chapter 3. It's because this is what most people know. Most people understand what we call measures of center. When we say average, we're talking about measures of center. But there's a lot of different ways of talking about the center of the data. Okay? And this is done in chapter 3, section 2. So I do want to talk about that today. So you'll notice that some people also asked, here's some of the words, and these are different types of averages or measures of center, you might say. Okay, and we'll talk about these in a little bit. What's called the mean, what's called the median, and what's called the mode. Here are questions you guys asked. You guys said these are easy to answer. Okay? I'll say that after I cover Chapter 3, Section 2, they'll be easy to answer. Okay? I agree. They're not hard. Location of the, help me out here, order. Of the order. Can you explain? Whichever group did that?
Well, like it never specified that they were all in a single McDonald's. They could be all over the country.
Yes.
Wait, no, I think it depends if it's in like New York City or like Wisconsin.
Oh, it does, right?
Yeah.
Different regions of the country you can travel to, and how long you expect to wait changes.
Or even a city.
City versus rural.
Right.
We know these things. There's a lot of things that influence it, right? I agree. The location of the order. So yeah, where did this data come from? Actually, maybe we can get some information from the presentation, right? Because we were looking right here. No, we were looking at the book. Although it's there also, which is interesting. So here.
Somewhere where there's no place but houses or
Yeah.
no businesses.
Yeah. You know, it's interesting because what you have here, okay, is what is called a sample. Right? I mean, you guys go to the Golden Arches and you see billions and billions served, right? And each one of those orders has a certain number of seconds it took to fill. Right? And maybe we want to answer, maybe I'm working for McDonald's and I want to know what's the average time my customer has to wait. And so what we do, the idea of statistics is the following. You really need to know two definitions here. And basically, I guess I'll say that these are Chapter 1 ideas, which I want to mention now, but then we're really going to start with Chapter 2. So just two Chapter 1 ideas that I want to get at today. Because I think that this is important for understanding what statistics really are. Okay? So here we go. I'm going to say that a statistic, and I'll underline it, I guess, because that's the word I want to get at here. And I'll say what it is a number associated with a sample. A sample. We have an example of a sample when I showed you that data on the screen. That's not all the times that McDonald's has ever had, right? And here's the other word I want to get at. A parameter, this is also a number, is a number associated to a population. So, the idea of statistics is this. The idea is that sometimes we can use a statistic to say something about a parameter. sometimes we can use a statistic to say something about a parameter. I want to go to the chapter 2 problem from the 11th edition of the book, which is the one that we're using in this course. Let me show it to you. Again, it's the intro problem.
12th edition.
The 12th edition is where the McDonald's problem comes from.
Oh, okay.
Okay, but we're using the 11th edition. I just like the problem so much, I thought, let me show it. Now, these books give you lots of good problems. So if I go to the opener of the 11th edition, well, here's what you get. I think it's back on page 41. Yeah. No. Notice that smog. And here we go. Here's the big question. Does exposure to lead affect IQ score? Hey, would that question be easy, hard, or extremely hard to answer? Ooh. I claim that's a higher level than some of our easy questions so far. Okay?
But it also is kind of more basic, so.
Yes.
It's not as easy as with and a hard aspect.
You're right. It's like an important question. In some ways, maybe the data is going to tell me right away. I guess it depends what the data looks like. But yeah, go ahead.
Kind of like looking at like how much data is given, an average or a median can be harder to figure out depending on how much is listed.
Oh yeah. I mean, that's one thing, is how do you handle large quantities of data, right? When I said the word population, the idea behind population is that it's too hard to handle all that data. That's what I mean by population. Finding the mean would be really hard. So what do? We take a sample. Look what this book says. Data set 5 in Appendix B. By the way, anytime you see this in our book, it's talking about data sets in the appendix. You should know that those are really large data sets. Your book has lots of them for you. And actually, we have them available for you on the computer to download. I don't want you going to the back of the book and typing them all in, although you could, in theory. Okay?
It seems like it would be too hard to figure out. I mean, because
Yeah, let me show you what we have. I'm just going to scroll down just a little bit. This is not all the data in the back, but it's some of it. I could have started with this instead of the McDonald's problem. What does it say? These are full IQ scores of the low lead group and the high lead group. See, some of the people were exposed to a small amount of lead. Some people are exposed to larger amounts of lead. And so we grouped them, right? I think there's also people that were not exposed to lead at all, and I think we have some of those IQ scores, but that's not considered in this particular problem. So here's the key question. Does exposure to lead have an effect on IQ score?
Well, you don't know initial IQs, like, and IQ changes over your life, so.
Sure.
It's like a learning.
Only by 5 points as most? See, these are things, you people are going into the healthcare profession, and I can't tell you, although we also have some people in psychology. I think IQ scores are interesting to those people. Nursing. As I heard what you guys said you want to study as a group, I said, you know what, let's go back to this problem. Does anyone know, for the population, what the, I'm going to use the word average IQ score is? Do you know, Kevin?
Exactly 100.
It's kind of set to be 100. That's the idea behind the test. The idea is that the center of the data should be 100. So if you see an IQ score above 100, that would be above average, and if you see below 100, that would be below average. I can't say much more than that until we get into the course a little bit. Okay? Are there people with above average scores from the high lead group? I could see them, right? And below average. And same thing with the low lead group. Now, very few people can look at data like this and expect to answer the question. And so what we do is we use the tools of Chapter 2, Chapter 3. Okay? And in particular, today, Chapter 2. And so where I want to get to, you notice, it says Section 2.2, we're going to talk about frequency distributions. And 2.3, we're going to talk about histograms. And that's just a fancy word for a graph, a bar graph, associated with a frequency distribution. Okay? So these two sections are kind of best taught together, and that's why we're going to go ahead and do that. So we'd like to do problem 24, talking about earthquakes. And so what I'm going to do, okay, I'm going to go to that Blackboard where you can download the different data sets. Here we go. So we clicked on Excel, and we got the nice set of files. And they have one for earthquakes, right? No? Well, I'm going to click on StatCrunch. And what it'll do, it's going to load something like Excel, but it's online. It's going to list all the data. And it gives you a lot of tools, okay? So this one's called quake.txt. We don't have that in our set? I guess not, huh? I'll check one more time. Okay. But anyways, we want to talk about depth. So how many miles down is the earthquake, right? You'll notice the range. Here's 10. Here's 7. There's a lot of data, right? And so what I'm going to do is I'm going to click on the data. And now this is not useful for you guys. You guys can't see this. I want to click on what's called a histogram. It says select column. I'm going to choose column B in depth. And I'm just going to press compute. So this is a visual representation of our data.
So will we be able to get it to?
Yeah.
Wait, what'd you do?
Okay. So hang on. So yeah, we'll have to get back to these later ones, but here you go. Okay. So what we have here, for example, exercise 4, this is an example of what's called a frequency distribution. Okay? You notice it says height and it says frequency. You guys see that? If I go back to the McDonald's problem, okay, maybe we can kind of close on this. There's something I could do which would make it a lot easier for you to I don't have it here right now. Oh, I have it here. Yeah. So, see, there's the drive-through service times. And we said it's hard to talk about the average per se. But then you'll notice here, I listed what's called a frequency distribution. You guys see that? Time and frequency. Time and frequency. Actually, these are called classes, the different rows of the frequency distribution. Look at the last class. What does the last class say?
275, right?
Yeah, 275 to 324. How many people were in that range?
2.
Only 2, right? So only 2 people had to wait more than 275 seconds. So when we said, do people wait 5 minutes? Well, occasionally it looks like in our sample that happened, right? Because 5 minutes would be about 300 right in the middle of there. So it happens, but not as often as waiting about 2 minutes. But see, if I'm just looking at the data, that's hard to understand, okay? And so I guess what I want to close with is I want to create a histogram that matches this frequency distribution. And since there are 5 rows in the chart, there's going to be 5 bars on the histogram. Does that make sense to you guys?
Yeah.
Okay? And so, as you look at the lower class limits and the upper class limits, what are those? Well, for the last class that you just talked about, the lower class limit is 275, and the upper class limit is 324, right? And so maybe what I can do here, okay, is I can do the following. I can draw a picture to go along with that chart, okay? So let's see if I can do that. Here, let me move this over here. No, that's too small. Well, we'll just put it back up. But what I'll do, if I make this a little smaller, maybe we can get this done. Yeah, there it is. Okay? So, let's see. As I make my picture, I should understand, from graphing and algebra, you have x and you have y. The y always should be frequency. Frequency. So this is our first example of what's called a histogram. The x-axis should represent, well, whatever it is you're talking about. So what are we going to put for the x-axis? We're talking about time, and what are the units? Seconds. Time in seconds. And so now maybe I can list some of the times. And I'm going to list the lower limits here. 275. Oh, no, that's the big one. I'm sorry. What's the smallest one we have? 75? Okay. 75, 125, 175, 225, and 275, right? And then it goes up to 325, right? So I may as well put a little extra. People would talk about the class width. How wide are the classes? Well, from 75 to 125, that's 50 seconds, right? So the class width is 50 here. And so you'll see some questions asked about that on the homework. Anyways, what's the highest frequency that we have? 24. So maybe what I'll do then is I'll say each one of these represents 5, and so I'll go as high as 25. And so I guess from 125 to 175, you'd have a bar that goes almost to 25, right? And from 75 to 124, they say, well, that's just over 10, 11. Right? 175 to 224 is 10. This is 3, and this is 2. Okay? And I'll be honest with you, I don't want you guys spending all your time in this course creating these. We have computers that can create them. But what we want to do is learn how to interpret. And so we're at 9:15. I'll come back with the data sets ready for you guys tomorrow. You come in with an attempt on some of the homework, and we'll go from there. Okay? Hey, nice work for the first day, and nice meeting all of you. Yes, I know.